So we're going to continue with soil physical properties, and the first one that usually I'm going to start off with texture. Now, before I even begin telling you what is soil texture, most of the time when it comes to soil science, usually we're going to pick the most convenient and the easiest technique for characterization. So physical ones is what I think of, because if you talk about chemical properties, you need reagents, and usually I put it back lah. Now, why do we start with physical properties? That is because most of the users of the soil or the land are usually the farmers. And when we talk about farmers, most of them, they are not very high income or not very well trained. So most of the farmers, they are poor and they have to rely on simple but effective techniques for characterization. And one of the best techniques to characterize the soil is the texture itself. So by testing it using your fingers, you know what kind of texture. And from the texture itself, you have some rough idea whether that soil is suitable for agriculture or otherwise. And not only texture is useful for agriculture, texture also is useful for construction, because a soft texture is usually a no-go, a no-no for civil engineers to build buildings. Although they can still build it, but they need to do something else. So you see why texture comes first, because they are the cheapest, they are the cheapest way for characterization, and the easiest, because the instrument lah, if you want to call it, the instrument that you want to use to analyze texture is your own finger and a little bit of water perhaps. Yeah. So okay, soil texture can be divided into several ones. There are many, not sure how many, but I'll show you the triangle later. And in that triangle, you can see like different kind of texture ranging from clay, sand, or maybe silt. In fact, these are the three components that form different textures in the soil. And of course, the moisture content also might going to affect a little bit of the texture as well. And most of the texture is defined based on the name itself from the first point, okay? The name of the texture, so you have sandy clay loam. If you have a mixture of everything, you may have sandy clay loam based on the proportion of the sand, silt, and clay. Or if you want to be more scientific, the soil texture also can be defined based on the percentage of sand, silt, and clay. So these are the proportion. If one of this component is more than the other, they give you different kind of texture. Okay, the feel is different. Maybe they are softer. If you have more sand, you can feel the grain of sand is coarser. If you have more clay, they are softer and they can be like stretched very long. So these are the things that you're going to know lah, and you can actually feel and determine. Okay. So once again, the texture depends on the proportion, the weight percent, okay, weight proportion between sand, silt, and clay in soil. Why they are so important? Because from there itself, you know whether they have water flow potential. Now, this water flow potential is how much of water they can flow through. Because why? You need water to flow through the soil in order to be stored in the soil itself. After all, water is important for photosynthesis. So that's one. And number two, if the water cannot flow through, most likely you're going to see flooding. So that is what happened in KL area, the developed areas, where water cannot flow through the concrete or the cement. So most of the flash flood lah, if any heavy rainfall happens. So that is why texture is very important. Yeah. Okay, number two, water holding capacity. Now this one depends on how small is your soil particle. If they are small, they will hold a lot of water. So that's why clay usually associated with a lot of water and whatnot. When you go to rice field, sawah padi, mostly planted from clay textured soil, which because why? Because paddy needs a lot of water, so that's why clay is very good. Yeah. And then number three, fertility potential. Now this fertility potential depends on how much of surface area does the soil particle have. So when it comes to surface area, the smaller the particles, smaller the soil particles, the higher the surface area. So, well, that is just one factor. There are many other factors as well that can define the fertility potential, but one of them is the particle size or soil texture. And then finally, suitability for many urban users like bearing capacity. Now, bearing capacity is how much of weight does a soil can handle. I mean, so usually number 4 is applicable for civil engineers lah, yeah, because what, you don't want a soft soil that today you build a building, tomorrow it collapse. Cannot lah kan. So texture can tell you that. So this is what I meant, the soil triangle, the soil texture triangle. If you look carefully at the tip, nearer to the tip of one end, it means they are like having a higher percentage of one component. Like for example, on top of here, on top of this tip, you can see like it is nearer to clay percentage. So you can say like if you're at the tip, that is 100% clay. So clay, of course you call it clay. But if you have more silt, you can see right here, percentage of silt. So this is where you can guess what are the range, okay, of percentage of these three components, sand, silt, and clay. And which one that are more suitable for agriculture, usually they sit in the middle. But of course, it depends on what you want to plant. Because if you want to plant paddy, of course you want clay. But most of the plantation that happens usually a clay loam, maybe a little bit of sandy loam. Sandy loam is not perfect, but usually we prefer loam or clay loam. So these are the textures that you can actually determine by using your finger. Of course, you cannot know the percentage exactly, because if you test it with your fingers, you can just guess lah whether it is loam, which group of them, and then you probably can guess lah the percentage, around what percentage that you have. Yep. So texture, we have talked about this, so let's skip. Now, particle diameter size. In last week we learned what are the particle diameter size for sand, silt, and clay. So once again, these are the summaries. Usually in determination of soil texture, usually boulders is excluded, as well as the coarse fragment. Those that are larger than 2 mm, they are usually excluded, because why? Usually when you collect soil samples, after you collecting soil samples, the boulders and also the coarse fragment is manually removed. And then after that, the sieving goes on. So you sieve to 2 mm, then you get, no, you sieve to 0.05 mm, things that are retained, that are sand, smaller, you sieve further until you get clay. So this is how we like determine the soil particle size. There are many ways we can determine this particle size. One which you can see like right here, like the sieve. Yeah. So in soil lab, you will always going to see some sieving going on right here. So coarse fragment, as you can see right here, big stones that lies around on the surface. If it's not on the surface, probably these big stones are probably in the bedrock, perhaps. So I won't going to explain too much. Sand, we have explained before, okay? So I won't going to talk too much about this one. Okay, one thing you have to remember, if it is sand, it usually in larger particles. So sand may exist in so many ways, because the sand can exist in the river. So sand can exist in a river. It also can exist in the desert. But one thing that you have to remember, the sand in the desert is very different than the sand in the river. Okay, the difference is that the sand in the desert, they are formed from wind erosion. That is why from the wind erosion itself, the sand in the desert, they are usually angular. They have angles and they are very fine. They actually can fall off just like as if it can fall off by itself. So the sand in the desert, they are not good for construction. However, if you say sand in the river, they are a bit spherical in shape, and they can hold up. They can hold up due to the moisture content. They're not as fine as the desert sand. They are a bit coarser, and because of the coarse texture, you can actually feel the grittiness. Okay, some grittiness to it. Uh, well, it's hard to how to explain, but when you rub sand particles with your fingers, okay, that feeling is called grittiness. Okay. Next one, the sand. Where can you find sand? You only can find sand near the A horizon, maybe A or B horizon between these two, but most likely you can find in A horizon lah. Now, sand usually they're larger in particles, so that's why surface area is not that high. It's quite low. And then sand also have less nutrient content because sand particles cannot retain organic matter. Things will just flow through it. It cannot retain it because they have less surface area. Okay, so the voids between them, they allow drainage. So water flows through, they can't trap anything. So that's why sand are not good for agriculture. And so that's why, well, you can actually see sand for yourself. So probably no need to test it. But some of the soils, they may have a little bit more of sand particles, but less of others. So testing the texture probably is a good idea lah, to test it out whether they have higher content of sand or not. Okay. Now the specific surface area is a very important parameter. However, because this subject is not physics, so I think I'm going to skip this one and going on for the next one. So the comparison between specific surface area between sand, silt and clay, as you can see right there. When you move from sand to clay, the magnitude of specific surface area increased by 4 times, maybe to 6 times. So then you can see why sand are so bad in agriculture. They don't even have like enough surface area for them to hold up anything. Yeah. So that is why sand only not good. But here's the thing: clay only is also not good. Okay, but before that, let's go to the silt. So this is silt and the size. Silt, you can hold it and you can mold it just like that. It doesn't feel gritty. It feels like flour, but it's not slippery enough. It is not that plastic. Not plastic means you cannot like mold it into shape and in a longer shape. It is not very sticky. It is sticky. It is not hot, coarse, but it is not very sticky. So um, that is the difference lah, between sand and silt. Yeah? So you can usually see silt near the river bed. And beyond that, I think because we don't have 4 seasons, so lowest is not applicable here. So you can usually find silt in the riverbed or maybe places where you have some movement of water. So these are the locations where you can find silt. And because silt are so small, they usually can retain a fair bit of nutrient inside because the smaller they get, they have enough surface area. So silt is also good. And that is why in delta area where silt is dominant, you can find that these are the reason why delta with a lot of silt, they are very fertile because they can retain nutrient. Now they can easily wash away, but they still have some weight. So they can be transported into anywhere like with a flow of river water. Okay. So they hold nutrient more than sand. And you can see like silt, they are usually the reasons why water they are polluted. Because silt, if you have a lot of siltation due to earthworks or maybe due to a sudden influx of high flow of river water, then you probably can see a lot of silt in the river. So as you can see right here, this is a meeting point between two rivers. One river is polluted, the other one is not, so we can see siltation. Now, frankly speaking, silt itself will not kill the fish, but because the silt may carry pollutants, so that might kill the fish or aquatic living organisms. So this one I'll skip because we have explained it. I've explained this one, so I just skip and I move on to clay. So clay is the smallest particles in the soil, and the size, as we have learned. Now, one thing that I haven't explained to you is that clay actually is not round. It is actually flat. It is plate with round shape or maybe a very long shape. It's very thin and that's why sometimes you call it flaky, because they're actually flat plates. Clay is not sphere. Remember that it is plates. As you can see right here, now this is the scanning electron microscope. This microscope is operating using electron, and you can see the very small particles of the clay is actually flake. You see, pieces and pieces of small layers of clay particles. So this is what it looks like. Yeah. And because of their small particle size, they can move very easily and they can be suspended in water. Now, suspended means like your milk, they mix well with water, but they don't dissolve. Now, things that do not dissolve don't give you transparent color. Now, the things like, for example, salt. Salt, if they dissolve in water, they give you transparent color like seawater. Seawater contains a lot of salt. However, clay is big. They mix well with water, but they don't dissolve. So they give you a milky mixture. We call it suspension. Or sometimes you also call it colloids, yeah. So they have large surface area because they are very small. Yeah. So you can see this person right here trying to mold the clay. I'm sure you have play with clay before. So they are very small, they are very sticky, and that's why it is very plastic. It can be easily molded into long ribbons, and yeah, this is how you're going to determine soil texture lah. If you want to determine how much clay, the longer this ribbon can form, the more clay content it will be. Yeah. But here's the trouble. If you look at here, this is how what it looks like in Malaysian soil. Very red, very clayey, and that is trouble because if it gets too clayey, water cannot goes in, so the movement of air and water is restricted. And when you have too much clay, this clay when they absorb nutrient, these nutrients are trapped because of the high surface area. Now plants cannot easily absorb, so they still can absorb those nutrients, but very hard lah. It is not readily available for them to absorb. Uh, but there's one more problem, the soil strength, because clay they also subjected to the effect of temperature as well. So if you still remember, clay contains a lot of water. When there's too hot, they will be evaporated. Now the trouble is when there's a loss of water, they will shrink a lot. But if there are a lot of water, they will swell a lot. Now this is the trouble here. If things can change so dramatically, that means it is not good for construction, because if they change so dramatically, it will crack the entire building. But that's not all, because these changes, this sudden change of shrinking and swelling from clay, also cause a lot of trouble with the plant root as well, because when they move, they shrink and they expand, it will going to damage the plant roots. Okay, now the last point is the chemical absorption is large. So is it good or bad? The answer is it can be a little bit of both. But I would say large chemical absorption is actually a good thing if you want to use clay for remediating or reducing pollution. Now, because they absorb a lot, so if you put it in a contaminated contaminated regions or contaminated area, most likely this clay will going to absorb this pollutant. And then what? Then you do further cleaning later. So clay usually is very useful, especially in the construction of landfill. You cannot miss clay. You always have clay in the construction of landfill, because clay, they are usually used alongside with polymer, geopolymer, as the lining. Okay, the walls. Okay, the walls of the sanitary landfills that we have in Malaysia. Uh, don't know what is this, so I will skip through and USDA textural class. Oh, by the way, the triangle that you see just now, they comes from USDA. And for your information, there are many triangles that we have. Even in Euro, also they have their own triangle. But the one we use here, we follow USDA, soil texture triangle. So there is it, this triangle, the same triangle that we saw just now. So it's quite safe to say lah, in your assignment later on, you're going to learn how to like what determine one of the characterization is a texture. Yeah. So there are like 12 textural class in which I will not going to explain each of them. So you go and see it. So I'll skip through and yeah, nothing much I want to say. The 12th class I will explain to you. You're going to learn it yourself. Okay, by the way, come back, come back. So there are 12 class. You may ask me, do you need to memorize all 12 class? I would say you don't. You don't. We don't memorize all these classes. But if you do, at least you already know three classes: sand, silt, and clay. Probably one more, loam. The others they are like a mixture of everything. So I don't see the point of you memorizing all this, but you're probably going to need to know how to use this triangle. Yeah, you better do, because apart from in your assignment that you have to know how to use this, you're probably going to see questions. Okay, now frankly speaking, in past year final exam question, maybe in test question, I have given students questions that ask students to explain how one experiment is carried out. And why this is valid? Because most of the experiment in soil science, they are way too simple not to know. Like the one right here, soil texture. I make it compulsory. I make it compulsory for students who enroll in soil science. They must know how to do soil texture. They have to know how to do it. So if they know how to do it, then of course, this is almost like a giveaway question in the final exam. You just rethink what you need to do, write it down, and there you go. You have your full marks. I probably will not ask you what is the percentage of clay, percentage of sand, silt, and clay for clay loam texture. No, that's probably beyond you. I won't expect you to answer that question, but I expect you to know how to conduct soil texture experiment, and probably there might be one small question that asks you what is this soil texture based on the percentage of sand, silt, and clay. So I give you the percentage of sand, silt, and clay and ask you, what do you think the texture of the soil? Of course, in order to ask you this question, I must give you the soil triangle, isn't it? Yeah, example lah. So I won't give you tough question, but I will give you applied question. Listen carefully. You probably will not find the answer from the internet if I give you that. And I already told you, in the exam, there will be open book exam. So you won't find the answer in the internet. You have to know how to do it. Otherwise, you won't be able to answer the question. So long story short, I won't ask you to memorize things, but I'll ask you to do things and ask you to write it down again, if only you know how to do it. Yeah? So these are the things that I will skip because it's, oh yeah, I think I will need to stop here for a while. So how do you change the soil texture? Well, if the soil texture is affected by the proportion of sand, silt, and clay, then you change accordingly. Okay. So although you can change the texture by altering the sand and silt and clay particles percentage, usually that is not advisable unless you are a civil engineer. You go to a soft soil in which that soft soil consists of a lot of clay. You want to build a high-rise building and you want to consolidate the soil. You want to make it stronger. What civil engineers will do is probably they're going to put boulders, large rocks, maybe large aggregates, or maybe at least they put sand. Because if they manage to put that in with more sand, it will increase the bearing strength, the bearing capacity of the soil. So that is for civil engineer. Now, what about farmers? Of course, farmers, one more time. There are some plants, there are some crops that are not suitable to be planted on a certain soil. Clay cannot, sand also cannot. So they have to be in between. What does the farmers do? Yes, the farmers can also do what the civil engineers do. They can also add a little bit of sand, maybe a little bit of silt. Frankly speaking, they don't add too much. They don't. They do add a little bit of sand, but most likely the farmers will do what this guy is doing. They're going to mix the sand with organic matter. So this is uh, what they call peat. Now, if you're into gardening, you will buy two types of growing media in the nursery. Number one is the red soil, the soil where you can get from anywhere. You don't even have to buy it, you just scoop it up from anywhere. Now, sometimes the soil is not perfect for agriculture. And before you even start agriculture, usually you need to mix it with a bit of everything. The biggest component in the mixture is organic matter. So either you put peat into it, or maybe you can put animal manure. Animal manure also is considered one of the organic matter that can mix with. Because why? Because organic matter, they are not heavy. They are usually light. Okay, they are very light. And why organic matter is so important is that if you have organic matter into the sand particles, for example, they will stick it and make it not so coarse. They will actually stick those sand particles. Okay. Now that is for sand. Now let's say what about clay? We learned about just now clay is not suitable because they're too sticky. However, if you have organic matter inside, this organic matter would tends to aggregate these clay particles and make it like larger aggregate, just like sand. So having organic matter is very good for agriculture because they prime it into the right size, the right particle size, the right aggregates. Not only that, organic matter is the source of nutrient. So okay, changing soil texture is very normal. People do it. But for agriculture, not only they add sand, they add a large portion of organic matter as well. So I think I will skip this one. Now, changing soil texture is not really a new thing because if you look at the soils around the world, agriculture has been around for so long. There are so many ways you can change the soil texture. Uh, in uh, in most areas, animal manure were used. If apart from animal manure, probably there are like some burnt charcoals. People also mix charcoals into the soil and make it darker because what charcoal is essentially a organic matter, but charcoal is a very stable organic matter because once you burn it into charcoal, that charcoal will last in the soil for around 100 years. It's not like the plants that you have like decomposed and then it probably lasts maybe 1 year, but charcoal lasts until 100 years. Probably more, probably a little bit less. So this is happening in Brazil, yeah. A lot of their soil, they have a special soil that they are prehistoric humans, They mix a lot of charcoal, so that's why they are special there. Okay, I think I will not going to explain too much. Oh, by the way, let me see. Okay, now for translocation. Now, translocation earlier we have discussed about it, and it's one part of the soil movement, and it's happening naturally. But sometimes when you look at it, in some horizon there might be some accumulation of clay. So this accumulation of clay, we have a term for it. We call it argillic horizon. Argillic means the accumulation of clay, and usually this horizon happens in the B horizon. So to better explain, to better represent this horizon, we actually use BT. Instead of B, they put a T. T is you can say is argillic lah. So what is the depth is up to like 100 centimeter, and which is true. So if you can dig a soil up to 100 meters, you probably can see this already, the B horizon. Yeah. So you probably won't going to do this because what? We don't have field trips because usually if field trips is allowed, I will ask students to dig a pit and ask them to evaluate the soil profile. So okay lah, you just learn from here lah. This is exactly what is how it looks like if we are allowed to have field trips, but unfortunately not in your batch lah. This is exactly what it happens. So people use their hands, get their hands dirty, dig a little bit of soil, put some water, and then just play like little child. And then they just mold, press, rub, see if they're gritty or not, see how long is the soil can be molded. So we determine soil texture by our fingers by feeling. So this is one compulsory things that you need to do lah. Now, okay, in all of the lab experiment, in all of our lab experiment for soil science, this is the only experiment that you must do at home because you can. What is needed in this experiment is your finger, a little bit of water, and also the soil triangle. So this is the only data that you cannot share. You cannot share data here because you can do it at home. I know you don't need to come to the lab. In fact, the environment is our lab for soil science. So don't worry. This is the thing that you need to do. Soon enough, lah. Maybe not now. Not now. You don't need to do this experiment yet. Wait until I finish the soil physical properties. So this is how it's done. You take a little bit of soil, spray a little bit of water. Well, they didn't say what water. So if you want to use any liquid, any fluid, you also can. If you don't have fluid lah, but make sure it's hygiene enough lah. Yeah. So soil, wet the soil, make a ribbon, see how long it can go, and then feel how gritty it is. Then you probably have some idea what texture is this. This one is another technique, but I would say this technique is more scientific one. It's called hydrometer method. Now, previously, when the times where students are allowed to get into the lab, we were going to do this. This is part of the experiment. And this experiment is based on one law they call Stokes' law, in which the velocity of the settling sand particles is based on the particle diameter. That means the bigger the particle, the faster it will sink down, which is true, right? Because when sand is very big, they have mass and it sinks much faster compared to the clay which is very small and then is suspended. So based on this different velocity of settling, scientists had developed an idea, an experiment on how to determine the soil particle size. Because from this formula, the faster it sinks down, you can actually determine probably around what kind of diameter from there. Yeah. So as I said just now, the bigger particles says faster and the density of water will suspend the lower density silt and clay. Yeah. And if the clay is suspended, the water density also becomes higher. And because of that, this hydrometer tends to float higher as well. So if they don't have like too much of suspended particles, it will sink a little bit. So based on this, and based on the timing of the suspension, we kind of like can guess. Okay, between what time to what time the sand will set. Okay, so from there you can determine how much of sand and silt. The timing is very important here. So most of the students previously they got all this data wrong because they have the timing. They can never get the timing right because why? Because this experiment actually takes 24 hours. This experiment, the hydrometer method, takes around 24 hours. They need to mix it, suspend it, allow them to suspend, and then after that, a certain fixed time, they need to come to the lab and measure using hydrometer. Now, here's the problem lah. They always have trouble with timing. The timetable. So it's not always they get the timing correct lah. Yeah. So the percent of sand, how the sand is being measured? Well, they just use a sieve and measure it. So in reality, in this hydrometer method, we determine the percentage of silt and clay, which are suspended right here. The sand usually is quite accurate because they just filter everything. More than 0.05 mm to 2 mm, these are the sand, which can be determined straight away by using sieve. So this is exactly what happens lah. There is a like large graduated cylinder. You can, this is exactly a graduated cylinder. The capacity is 1 liter. And we call this what, I forgot what is the name. Let's see, we have a name here. We have a name for this glassware. Is not graduated cylinder. If not mistaken, is forgot lah what is the name. But you can see lah. I mean, after this, when you check the lab manual, you can see lah what is exactly the name of this glassware, and the capacity is 1 liter. Less than 1 liter probably is not accurate, but this is the one that people use to suspend the clay particles. I mean, these are the soil water, and then they use hydrometer to measure how much they sink based on different timing. Yeah. So how does it calculate it? I mean, based on this formula,